Okay, we will go over the definition of log.
So what is the meaning of a log? So in log, first log cannot exist alone. You have to log a number. Let's write the number as b. And for a log, you also need to do every log with respect to a base. For the base, it would be a little number down below next to the log. So let's say the base is a, and when you log a number with respect to some base, you will get an answer. The answer is also a number. Let's say it would be x. In such a case, if I tell you that log b base a is x, it will be the same as if I told you that a to the power of x equal to b. Okay? It's a to the power of x equal to b. Now with this, you should be able to figure out what is log 8 base 2. Yes, the answer is 3. Why? Because 2 to the power of 3 would be 8. Okay, let's try one more. Log 9 base 3. What is the answer? Come on, it's not 3. It's 2. Why? Because 3 to the power of 2 is 9. Okay, let's try more. What about log 1 over 27 base 3? Okay, 1 over. What kind of power would give you 1 over? The answer is a negative power. And since 3 to the power of 3 is 27, the answer is negative 3, right? Because 3 to the power of negative 3 would be 1 over 3 to the power of 3, which would be 1 over 27. If you're not familiar with the meaning of a negative power, you should go back to the last section on the law of exponents. Next, what about log 2 base 4? Well, the answer is half, because 4 to the power of half is 2, right? Because 4 to the power of half, the meaning of a half power is a square root, and root 4 is 2. Okay? Next, what about log 0 base 5? Okay? Give it some thoughts. Answer will be coming 3, 2, 1. For any student that do not give an answer, you'll be right. Turn out this is not possible. Because 5 as a number, when you raise 5 to no matter what power, you will never get 0. Okay? You might say, wait, what about 1? Don't we have that have something to do with the power of 0 is 1? Well, that is true. But that's only that if you raise 5 to the power of 0, you get 1. What that means is if you have log 1 base 5, you get 0, right? Because 5 to the power of 0 is 1. Okay, don't mix this up. Next, what about log 5, log base 5, negative 25? Answer in 3, 2, 1. Again, whoever do not give an answer is right. Because again, a positive number, which is 5, when raised to no matter what power, would give you a positive number. right? You may think, what about raised to a negative power? Well, negative power simply means 1 over it, 1 over 5 to the power of 2. Since 5 to the power of 2 is still positive, 1 over a positive number is still positive. So it is impossible for 5 to give a power of a negative number, right? So as you can see here, the number that you're trying to log, this number that you're trying to log, cannot be negative and it cannot be 0. So as a rule, b has to be bigger than 0. Okay? And for reason that we will cover in topic 2 in the section of functions, it turned out the base a also cannot be negative, cannot be 0. So a is also bigger than 0. Okay? And we also make the additional rule that a cannot be 1. A cannot be 1. The reason is this. Imagine you have a base, you have a log with base 1. Okay? Then if you think about it, 1 to no matter what power, no matter what I put here, okay, I might put 4 or whatever, 1 to the power of 4 is still 1. And even if this is not 4, but anything else, you will still get 1. So if the base is 1, it will be very boring. B is just always 1. Therefore, as a rule, we also do not want A to be 1. So this is the most important thing that you should know about the definition of log. But there is other stuff that you can do. For example, it is possible for me to give you an exponential relationship. For example, 4 squared is 16. And you might want to write this as a log. You should pause the video and try it on your own. Answer coming in 3, 2, 1. Okay, the answer is log base 4, 16 would equal to 2. Did you get it right? Now, if you think about it, it's because 4 to the power of 2 is 16, which follows the definition of log. Let's try one more. Uh, let's say 5 to the power of negative 3 is 1 over 125. Let's write this in log. Give it a try. Answer coming in 3, 2, 1. Well, it's log 5, 1 over 125 equal to minus 3, which makes sense because 5 to the power of negative 3 is 1 over 125 as it's given. Okay, the last one. Let's try this. What if I say y equal to a to the power of x? How should I write this in log? Give it a try. 3, 2, 1. Now, if you need more time, you could really pause the video. But the answer is base a y equal to x. Because again, we go around anti-clockwise, so a to the power of x would give you y. So this is the definition of log. Now, before we go, we have two special log. The first one is something like log 1,000. Okay? You may have noticed the lack of base. Now, actually, log have to have a base. So the base isn't really lacking. It's just that we are too lazy, and mathematicians have decided whenever the base is 10, it is okay to omit it. So if a log have no base, it really means 10. Okay, so think about it. What would be log 1,000? Answer coming in 3, 2, 1. Okay, the answer is 3. Whoever said 100, think about it. 10 to the power of 100 would be 1 followed by 100 zero. Okay, I don't even have space to write that out. Okay, so it's 3, 10 to the power of 3 is 1,000. So that's the first special log. Whenever the base is 10, we can omit it. A base 10 log is called a common log because it is used pretty commonly. But there's another one, there's another log that is special, and that is called ln. So usually we write like ln something, like ln x. Now ln is still a log, but it's a log of base e. Now what is e? E is a special number. Its value is roughly 2.7. Okay, it's 2.71828, blah, blah, blah. It's kind of like pi. Is non-recurring, non-terminating. So it's basically an irrational number. You cannot write out all the digits. So that's why, like pi, we use a letter to represent it. It's called E because of Euler, one of the greatest mathematicians of all time. E is also called the natural number, hence Ln. Ln stands for the natural log. So Ln is also used very commonly, especially later on in some other topics such as differentiation. You'll see, just follow my videos. And yeah, so don't be scared by Ln. Ln basically is a log. And so it has all the properties of log, as we'll see in the next section. And also it follows the definition of log. For example, if I ask you what is ln e to the power of 3, okay, give it some thought. What would it be? Is it coming 3, 2, 1? The answer is 3 because if you think about it, ln means a base of e. And so by the definition of log, e to the power of 3 would give you e to the power of 3, right? E to the power of 3 gives you e to the power of 3. Therefore, ln e to the power of 3 is 3. So this should conclude this section. I'll see you in the next section on the properties of log.